Good day, students. Welcome to mathgotserved.com. And this clip we're going to be going over problems 31 to 35 of the ACT Math Practice Test. Alright, question 31 reads, to make a 70-50 piece jigsaw puzzle more challenging, a puzzle company includes 5 extra pieces in the box along with the 750 pieces, and those 5 extra pieces do not fit anywhere in the puzzle. If you buy such a puzzle box, break the seal on the box, and immediately select one piece at random, what is the probability that it will be one of the extra pieces? Alright, so before we solve the problem, let's go ahead and write down the formula for the probability of an event occurring. Okay, so the formula is as follows. So the probability of an event occurring is basically the possible outcomes. Think about success, okay? Possible outcomes divided by the total number of outcomes. Okay, total number of outcomes. Okay, so in this problem, if you think about the possible outcomes or successes, what is that going to be? Possible outcomes or the desired outcomes happen when you select one of those extra pieces. Okay, so it says what is the probability that it will be one of the extra pieces? So how many extra pieces are there? There are 5 extra pieces. Alright, how about total number of outcomes? Total number of outcomes are all the possible selections that you can make. Okay, so total outcomes, how many pieces are there in the box when you just open the seal? Well, normally there should be 750, right? But they have added 5 more puzzles in order 5 more pieces in order to make the puzzle more challenging. So we have a total of 755. So you want to be careful with that. So now let's go ahead and select the probability of selecting one extra piece. Probability of selecting one extra piece is the possible outcomes, possible successes, which is 5, divided by the total number of outcomes, which is 755. Okay, so this problem you do not have to reduce. If you take a look at the options, you can clearly see that our answer is option letter D. Alright, let's take a look at question 32. It reads, what fraction lies exactly halfway between 2/3 and 3/4? So let's start out by writing down what the formula is. So if you think about halfway, you think about the midpoint formula, okay? Either the midpoint of the x's or the y's. Let's look at the x's, for example. So the formula for the halfway point, halfway, between 2 points on, let's say, the x-axis, between x1 and x2 is going to be, so the halfway is basically the average. So x1 plus x2 divided by 2. Okay, if you recall the midpoint formula in geometry, that should basically give you an idea of what we're talking about. So if you want to find the midpoint is basically halfway between the x's and the halfway between the y's, given 2 points, x1, y1 and x2, y2. So we're just extracting one of them, namely the x's, and applying it to this scenario. Okay, so we have, let me give you a visual here, 2 numbers, x1, which is 2/3, and x2, which is 3/4. And the question is, right at the center of these two, what is that? What is this going to be? That's what we're looking for. Okay. All right. So let's go ahead and calculate it. As indicated earlier, x1 is 2/3, and x2 is the second one, 3/4. So the halfway is going to be x1 plus x2 divided by 2. Okay? So you can simply plug this into your calculator and get what the answer is. Let me show that to you real quick. We're going to be using the TI 83 for this computation. So you just go parentheses 2. Well, let's do this. We're going to group the 2/3 in its own parentheses. So parentheses 2 divided by 3 plus parentheses 3 divided by 4. Close that, close the top, divided by 2. Okay, and then you can change that into fraction form. If you desire to change it to fraction, just simply press math and then press enter. So what happens here is that it calls up the previous entry, and this arrow means convert to fraction. Press enter, 17/24. Our answer is option letter K. Okay, now let's assume that you don't have a calculator with that functionality. Let's go ahead and do this by hand. Okay, so if you want to add two fractions, you need to have the denominators equal to the LCD of the denominators. So the LCD of 3 and 4 is 12. So let's show you how that happens. So they have nothing in common, so I need to multiply this by 3, top and bottom. And 3 I need to multiply by 4, since they do not have any common factors. So if we express them as the LCD, two equivalent fractions with the denominators equal to the LCD, we have 8/12 plus 9/12. Now I can add because the denominators are identical. How do you add fractions? You add the numerator, keeping the denominator the same. Now we have a complex fraction scenario. How do you evaluate 17/12 divided by 2? What you do is express the numerator and denominator values as fractions. So 2 was not a fraction before, so we just put it over 1. And what you do is you drop, change, flip. Okay? So you drop the numerator fraction, 17/12. You change your division to a times, and you flip the denominator. What we're doing is multiplying the numerator by the reciprocal of the denominator, which is equivalent to dividing. Okay? Now how do you multiply fractions? You multiply horizontally. Okay? Numerator with numerator, 17 times 1. And then denominator with denominator, 12 times 2. As you can clearly see, our answer is option letter K. Alright, let's take a look at question 33. It says, Gianna is converting a 12-foot by 15-foot room in her house to a craft room. Gianna will install tile herself, but will have CC Installations build and install the cabinets. The scale drawing shown below displays the location of the cabinets in the craft room. We have 0.25 inch represents 2 feet. Cabinets will be installed along one of the 12-foot walls from floor to ceiling, and 4 cabinets that are each 3 feet tall will be installed in the middle of the room. These are the only cabinets that will be installed, and each of them will be 2 feet wide and 12 feet deep. CC Installations has given Gianna an estimate of $2,150 for building and installing the cabinets. Question 33 reads, a 15-foot wall is how many inches long in the scale drawing? Okay, so one thing I want you to note concerning a scale drawing and the actual object, let's write that down, is that a model and the actual figure are similar. Okay, if you think about similarity in geometry, what does that mean? It basically means that corresponding sides are in proportion. So if you divide corresponding sides of similar figures, you will end up with a constant known as the scale factor. Okay? So that's what we're looking at here. So let's go ahead and write down the formula for this problem. Formula is as follows. This is the scale factor formula. Okay? So the scale factor formula basically tells us that the scale factor k is equal to the model measures divided by the object measure. Okay? Or you think about the object as the figure measure. So let's write this down. The scale factor is equal to the model measures. We're talking about corresponding sides here, okay? Not just any measure, okay? Sides are corresponding one another. So let me write that again. Model measures that divided by your object measures. Okay, so in this problem, we are asked to find what again? A 15-foot wall is how many inches long in the scale joint? Okay, so we have the actual and the scale. If we apply it to this formula, the model is the scale drawing, and the object is the actual. Okay, is the actual measurement itself. Now in this problem, we have let's list what we have. We know what the scale factor is. The scale factor is given right here. You're told that 0.25 inches on the scale drawing. That's the scale drawing. Represents 2 feet on the actual figure itself. Okay? So that's just by the way. So the scale factor is basically 0.25. 0.25 divided by 2. Okay? So model over object, or scale drawing divided by the actual figure. Okay, and then what else do we know? We know that the model measure, or think about it as a scale drawing in the context of this problem, is not known. We don't know, but we know that the object, basically the actual cabinet itself, is 15 feet, right? So we have, it says, oh, the 15-foot wall will be how long on the scale drawing? So the object, the actual measure is 15 feet. Okay, so if you have 15 feet on the actual installation, the actual room, what will it measure on the little drawing on the paper? That's what we're looking for. Okay, so let's go ahead and write down the formula that we're going to use again. So we have k equals scale factor equals the scale joint divided by the actual figure. Scale factor is 0.25 over 2 equal to the model or scale joint is unknown, which is x, and the actual measure is 15. Now we're going to solve this resulting algebraic equation. To do that, we need to get x isolated. We have x divided by 15 here. To undo division, we use multiplication, so multiply by 15 on both sides. And then we can simply enter this expression into our calculators to get what the value of x, the scale drawing measure, is. Okay, so where's my calculator? Let's call it back up. So we have 15 multiplied by 0.25 divided by 2. And we have 1.875. So 1.875 on the scale drawing will represent 15 feet on the actual installation. So our answer for 33 is option letter B. Now let's take a look at question 34. It says Gianna will install tile on the portion of the floor that will not be covered by cabinets. What is the area in square feet of the portion of the floor that will not be covered by cabinets? Okay, so if you take a look at the drawing right here, we have cabinets here and cabinets here. So we're looking for this area right here, the area that's not covered by cabinets. Okay. All right, so let's go ahead and write down some formulas that will guide our problem solving process. So the first one has to do with what the area of a rectangle is. So what is the area of a rectangle? Area of a rectangle is length times width, right? So area of a rectangle, A, is length times width. Second has to do with area of a portion that's covered. So area of a covered area, let's call it area of covered. Area of covered, we're just basically doing arithmetic with areas, okay? So area of covered is simply going to be the area uncovered. So area of covered is going to be the total area subtracted by the area that's uncovered. Okay, area uncovered. Okay, in this problem we're looking for area uncovered, so let's rewrite this formula. So area uncovered, which is actually what we want, is you just interchange area covered with area uncovered, is equal to the total area minus what? Minus the area that's covered. Alright, that's more like it. So in this particular problem, if we think about the area that's covered, is just the area of the cabinet, okay? And the area that's uncovered is the blue region, which is what we're looking for, okay? So this blue area right here is area uncovered. And then this black region right here is the area that will be covered by the cabinet. We're not going to look at this area right here because we're just going to subtract it from the entire measurements. So what do we have? If we just take this square portion out, which is what I'm about to do, take out this square portion, what will the dimensions be? It's not actually a square, it's kind of smaller than that. So let's use a rectangular measurement here. So let's say we have a rectangle here for that portion. Okay. So let's pull out that rectangle, and in the center we have the cabinet. Okay, so if you notice what I did here, I ignore this portion, right? Because that region will be covered, so we don't really care about it. So the entire measure is 15 feet. Okay? So if the entire measure of this wall is 15 feet and this portion is 2 feet, then what's left? What's left is 15 minus 2, which is 13. Okay, so this portion is going to be 13 feet wide. And how long will how was the height or the length of this region? Is going to be 12 feet, right? So you have 13 by 12. So from here to here is going to be 12 feet long. Alright, so with these dimensions we can find the total area. So this is the total area right there. Okay? So A total is going to be simply the area of a rectangle, right? Length times width, which is, this is our length, and this right here is our width. So it's going to be 12 times 13. 12 times 13 is 144 plus 13, which is 156. All right, now let's go ahead and write down what the area of the covered region is. Area of covered is basically the area of the 4 cabinets that we have. Okay? So let's write that down. Area of 4 cabinets. And we're told earlier that each cabinet is 2 by 2. Okay? So the area of 4 cabinets is going to be 4 times the area of each one, which is 4 times length times width, the 2 by 2, which is 4 times 2 times 2, which gives us 16 for the area of the 4 cabinets. Each cabinet has an area of 4 square feet. Okay, so we have area total and area covered. So this is, it's something like this. We have 4 cabinets here, and each of them are 2 by 2, so that gives us a total of 4 by 4. So this is 2 by 2. Okay, so you can clearly see that the area in here is going to be 16 square feet. Alrighty. Okay, so the area uncovered. Area uncovered, we talked about this before, is the area, the total area minus the area covered. So the total area is 156, and then we subtract the area covered, and we end up with 140 square feet. Our answer is option letter H. Alright, let's take a look at question 35. It says CC installation estimates consist of a 650 charge for labor plus a fixed charge per cabinet. The labor charge and the charge per cabinet remain the same for any number of cabinets built and installed. CC installations would give Gianna what estimate if the craft room were to have twice as many cabinets as Gianna is planning to have. Alright, let's start out by writing down the formula for the total cost in this particular scenario. So, formula is as follows. The total cost is comprised of 2 components. Okay, we have the base charge for labor, which is independent of the number of cabinets ordered, plus the total charge for X cabinets. So this component is dependent on the number of cabinets that are installed. Okay, so in this particular problem, if you dissect the area that she wants, you figure out that she needs a total of 10 cabinets, but that's not really important. So let's just let X B, the original number of cabinets um, Gianna orders. Okay, Gianna installs. You could use 10, but it still be the same answer. Okay, so her original, we have original cost, the original scenario. If you go back to the problem, we're told that the original estimate was 2,150. Okay, that was the original, and that is made up of a base charge of 650 plus the charge for X cabinets. Okay, charge for X cabinets. Now, how much do you think she gets charged for X cabinets or for 10 cabinets? You simply subtract 650 from both sides. So the charge for X cabinets is going to be 2,150 minus 650. So let's see what that is equal to. Where's my calculator? 2150 minus 650, and it's 1,500. So this is the charge for X cabinets. Okay. Now the reason why we don't need to figure out the exact number of cabinets is because we're simply doubling the total. So this is the charge for X cabinets. Now what happens if she orders twice as many cabinets? Okay, so in that case we're looking at the charge for 2X cabinets. How do we figure that out? We just simply double the $1,500 charge for X cabinets, right? 2 times 1,500, which gives us 3,000 for twice as many cabinets. But is this going to be her total cost? The answer is no. Remember, the charge has two parts. It has a base charge and the charge per cabinet. Okay, so if we have double the number of cabinets, so double the original order, the original estimate. If we double the original estimate, the total cost is going to be the base charge of 650, which is independent of the number of cabinets ordered, plus double the cost for X cabinets, which is 3,000. And the final amount is going to be 3,650. Answer for number 35 is option letter D. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming ACT exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial, just post your questions in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.